is Pete Barrie with Sani-Matic. Kind of a fancy title, using OEE to unlock operational improvement in sanitation. We'll definitely talk about OEE, but in a broader sense, it's a lot of efficiency gains in sanitation and cleaning through digital reporting, particularly cloud reporting, so opportunities to do that. So revolves a lot around kind of, obviously a lot of hygienic design principle discussions the last couple of days. We're kind of going more into the, okay, we're cleaning and how do we get that cleaning process even faster. Quick introduction to myself and Sani-Matic. I'm the product management director at Sani-Matic, chemical engineering background from UW-Madison. If you don't know Sani-Matic, we do automated CIP, clean in place, and COP, clean out of place solutions, as well as some hygienic component solutions, spray devices, strainers, things like that. So most of my career has been in the hygienic process industry, manufacturer, pharmaceutical end user, mostly at Sani-Matic, some other pharmaceutical end user facilities. So this is the agenda. We'll go through this in a second here. I hope all of you got to attend Loan's presentation this morning. I think it was the third one. I really enjoyed that one. That was a really good one. There was a particular slide that I paid attention to, the time that sanitation got to clean, and it was that charts. And I think it varied from 5 or 6 hours all the way down to 20 minutes at one point. I don't know what the heck they did in 20 minutes. I don't know what kind of plant and how big that plant was, but I can barely get my dishwasher loaded in 20 minutes. But that was really interesting because obviously a lot of the things we've been discussing today and yesterday, hygienic design and making things easier to clean on the processing equipment side, allows you to clean faster, to sanitize faster. Whether it's open plant cleaning, so things like wash down of conveyor belts and frames and the actual plant. And we're going to focus more here on COP, clean out of place, and then automated CIP. So when you implement those type of systems in your facility, you are typically cleaning faster. But then once you run those systems, there's lots of areas for your operators or the actual equipment to clean not as fast as you would like to clean. So if your day one of your CIP system that you install is cleaning in an hour, a year from now, it might be cleaning in 2 or 3 hours because it has become less efficient, whether it's through poor operator training, new operator turnover, or utilities are changing, things like that. So a lot of today we'll talk about just how digital data recording, specifically cloud-based recording, there's some benefits to that, and I'll go through that as well, how that can improve the overall time to clean. We'll talk about OEE as kind of a subcategory for that. So we'll go through an overview of digital data recording. I categorize the benefits so the end user plant could see into 2 main categories. One of them is more, hey, I need to clean and report on this cleaning data. I have temperatures, I have conductivities, I have time that I clean that I need to record, so I'm going to do that with this digital data recording software tool, but also a whole bucket of tools and insights for improving the efficiency of the system, which is what we just kind of talked about. And that goes from OEE to notifications, training opportunities, preventive maintenance opportunities, reducing downtime and things like that. And then with the cloud system, there's benefits of the equipment supplier, in this case the CIP or the COP equipment supplier, to be able to see that data, because oftentimes they are the subject matter experts to be able to say, hey, I see inefficiencies in this use of the system, or this utility is taking a long time to perform, a drain step or a chemical fill step. And from that, you need to here's some recommended actions you can take. So just as an overview here, what we're talking about is a lot of times moving from paper-based. I'll use chart recorders a lot as an example. I don't want to pick on chart recorders, but I'm going to pick on chart recorders, paper chart recorders. All of you have probably experienced them in some form or matter. But whether it's a paper chart recorder, whether it's maybe it's an inefficient digital solution, or it's a logbook, or whatever it is, moving to more digital-based recording solutions, and specifically maybe some cloud-based solutions as well. And like I mentioned, this is really applicable to automated clean-in-place systems. When you think about automated cleaning, you might think about CIP right away. So this is definitely a big area where this can get implemented and a lot of the efficiencies can be realized. On the COP side, your plant might have COP parts washers, so the big tubs, and you put parts in and kind of do your chemical wash inside those. Or if you have what we call parts washers or cabinet washers, think of it like a big dishwasher. Those are really just an automated CIP, but you're putting your parts inside of that cabinet. So the same temperature, conductivity, time, control factors are all the same in that type of a washer as well. So all the examples I give are kind of applicable to both the automated COP and the automated CIP. I mentioned the two major groups of benefits here. So when someone's looking at digital data recording, they're probably thinking, in my experience, they're more trying to automate the data recording of the actual wash cycle. So whether it's CIP or COP, they've gone through their FSMA critical control points, and they're monitoring, again, conductivities, chemical conductivities of the wash, the times that they washed, their sanitizing time, things like that. So moving from paper-based to the digital-based has some efficiency gains from just collecting that data and having it be automated and hands-off. But then there's a big realization of tools and insights for improving the efficiencies, and we'll go through those over the next couple of slides, and hopefully that becomes more apparent on what those can be. This is just a screenshot of what the online portal for that data could look like. So you see, temperature, conductivity, flow, all those critical data easily reviewable with different wash cycles. So if you have a line circuit, if you have different tank circuits, able to review that all in an operator interface in the cloud. Again, much more user-friendly access than a paper chart recorder. A lot of facilities have multiple dozens of these paper chart recorders, so the simple act of collecting that data is a lot of work. And with this, you can add all sorts of additional insights like cycle IDs, recipe step data, and we'll talk about all this stuff more in a few slides. So one of the operational improvements I mentioned just from a workflow comparison, so this is, again, I'm going to pick on the paper-based chart recorder a lot today, and then compared to like a cloud-based digital chart recorder. There's just a lot of work in regards to actually collecting and managing and storing that data. So if you think about the operational workflow of a quality person, there's a lot that goes into that paper chart recorder. Our field service team and a lot of our team that goes out and looks at these CIP systems, a lot of times the paper chart recorders are just not maintained, right? So maintenance is not installing the pens, the paper's not there, it's not working. So that's just a whole headache in itself. But then most of these charts are 12 or 24-hour cycle-based charts. So you're going to have to retrieve, store, sign off, paper sign off, get them to the right person, and then file and store them. And if you have an auto activity, you have to go get those from off-site and bring them back. And so there's a lot of actual work that's going on. Out on the actual sanitation side, we have this 20-minute, 6-hour, 8-hour window of sanitation, and we want to clean as fast as possible. So all these additional steps are just things that we want to be, as efficient as we can on. Versus the digital data recorder, it's just automatically there. So we're always connected from our equipment, sending up the data to the cloud, and the review and the storage is all in just one place. So this slide just kind of has a spattering of some of the tools and insights for improving the efficiency side, and we'll dive into some of these in more depth. But everything from dashboards to data trending, preventive maintenance tracking, we'll look at that more in a few slides, email text notifications, and then we'll talk about OEE trending as well. But it's a place where there's just none of this is particularly tied directly to the cleaning cycle data recording, right? So if an auditor comes in and talks about, hey, let me see your cleaning cycle records, your critical control points for cleaning, they're not going to really care about dashboards or PM tracking or whether you got email text notifications on things or what the OEE scores of your CIP were. So they're not directly cleaning cycle related and regulatory related, but they're very relevant to improving the operation of your actual system and how your operators interact with that system. So the first one I'm going to talk about is the OEE side, and the one that was in the title of the presentation, so maybe one you're looking to understand most. OEE, often used on the process equipment side. No reason it can't be tied into something like a cleaning system. So in this case, these are all specific availability, performance, quality, and overall OEE scores. Those are three common parameters of OEE, specifically to a cleaning system. So let's tie this to like an automated CIP system. You can score and tag a score, and it's in a percentage base, 0 to 100%, each of these three performance, availability, quality to something like a CIP cycle. And for availability, you can calculate it so that it answers the question, how often is my clean system actually being used during planned clean time? So if you're running a CIP cycle and it's an hour long, let's say, but an alarm comes up and it stops the system halfway through, 30 minutes in, maybe an operator didn't actually see that alarm and come back and do anything for an hour because they were off doing something else. So they come back, they fix the alarm state, they hit start, the CIP cycle finishes that last half an hour of operation. In that case, you actually used 2 hours for that sanitation of that CIP, but you only really needed an hour. So in that case, we're going to take it with a 50% availability score. So what this does is it really starts to bring visibility into what's going on with your CIP cycles. And then you can, in a few slides, we'll talk about how obviously that leads to training examples, diagnostics of, hey, why did that alarm happen? What can we do about it? And some more information is power. You're going to be able to look into it and dive into it and improve upon it. So things, specifically the alarms, and if an operator did stop that system for some reason and the system was idle, that would hit the availability score. On the performance side, so this isn't necessarily a stopped CIP cycle. Again, I'll use CIP as an example. But if you're familiar with CIP, you're doing a pre-rinse, you're doing a chemical wash, you're probably doing a post-rinse, and you're probably doing a sanitize step, right? That's kind of the basic phases of CIP. There's a lot of things going on to make those cycles work. So you're filling the tanks, you're draining the tanks, you're heating up the water, you're adding chemicals. So there's a lot of what you can kind of call non-value add. You're not actually cleaning something when you're heating up that water at the CIP system, but you have to do it to get that solution up to temperature and up to chemical concentration. So the faster you can do that, the better. So on the performance side, what you can do is look at all those times that we're not actually adding value to the system and have that be degradation on the performance score. So if I went through and I could fill automatically, I could drain fully automatically, I could add chemical in a second and get up to temperature in a second, I would get 100%. But in this case, we're always kind of below that. But the big thing here is over time, as I mentioned, a lot of times companies will be, hey, my CIP ran in 90 minutes when I started, and 2 years later, it's now at a 3-hour cycle. So what happens over time is people do things like my water supply coming in, maybe this was the CIP system was the dedicated supply for that water line. Now we've added a bunch of other equipment and they're pulling additional water drops. And now my water pressure is a third of what it was before. So it takes 20 minutes to fill up my CIP tank instead of 5 minutes. So you can start to see some of those degradation in performance. And then again, the plant can address, hey, do we want to put a larger or a dedicated water line supply to that CIP? Same thing with like heat exchanger scaling. If you're getting an efficiency in the heat exchanger performance over time, it's going to heat up slower. It takes 20 minutes instead of 5 minutes to heat up. So you can start to see those type of things. And then finally on the quality side, so this one's kind of a hit or miss. You want to see 100%, and if you don't, it's going to be an issue. How we do that or how we calculate that one is if any aborted cycles, so if you are running through your CIP and you abort it in your chemical wash step, that's not a good cycle. We didn't get through the sanitize, we didn't get through all this stuff. Or if you skip through steps. So the way that we program our systems is at certain maintenance and certain engineer levels, you can skip through things for testing. We advise our customers that hey, you should have a operator level login, and they can't skip through that, but a lot of times people just leave the admin logged in. So if someone's skipping through, hey, I want to get through this sanitation step faster, and I skip through it, I would see a not 100% score on that OEE. And as a quality reviewer for that, I could say, hey, something didn't happen right on that one. Overall, each of our cycles, whether it's automated CIP or COP, you can tag a value to that, and then when you see that cycle pop up in your user interface, I want to see 100% all the time, but if I'm seeing less than that, it's probably some alarms are happening. I can do some troubleshooting and investigation to what's going on there. Performance side, I want to see consistent values, and if I start to see drops, I know things are going on probably with my utilities. And then the quality side, I want to see 100% all the time. And then that overall OEE score is just a multiplication of those three together, so kind of a quick overall, how am I doing? Efficiency gains on notifications. Being cloud connected, we can do fun things like send emails and send text alerts. And if an event happens with our system, whether it's a cycle being completed or a system being aborted or a certain alarm coming up, individual users or operators or quality or maintenance or whoever's part of the system can get notified. So simple things like a quality person being notified that a cycle's done so they can go review it can be done. And what that does is it just kind of speeds up the process of things happening. So the review process is faster, specifically like alarms coming up, and I mentioned that availability where if an alarm comes up that stops the system, you want people to be notified of that, so you can set up alarms for that. So that becomes a more efficient process on just getting notified right away and taking applicable actions for that. Training opportunities, with all this information, again, you can review events and find inefficiencies, errors, and typically how your operators are using the system. So I've talked to sanitation managers or plant managers that are clean shifts are happening overnight and they're not always there to oversee it every night. And just being able to come in and, okay, the CIP took much longer than was thought, or a lot of issues came up. being able to see exactly what type of alarms came up, which operators were logged in, what they did with the system, and then being able to train on that is very beneficial for a lot of sanitation leads and plant managers. PM tracking, I think it was in one of the first sessions on Tuesday. Yesterday there was talk about PM, of gaskets and things like that, so replacing things annually. So that's always a good practice, whether it's tri-clamp gaskets on a CIP system or pump seals, valve seals, things like that. You can also do things like tracking preventive maintenance cycle times of the pumps or valve cycle count. So how many times is my valve actually opening and closing? So if you do have high wear items, so things like a chemical caustic pump, that might be a point of, hey, that thing is failing every 8 months, 9 months or so. And you can actually set up and see next time, all right, I replaced that chemical caustic pump. I'm going to put in an alert to say next time that runs 1,500 hours or whatever it is, I can get notified via email or text that that's coming up for a PM and that specific item needs to be addressed. And just a lot of reducing downtime. If any of these items fail during a specific sanitation run, it's going to prolong that time for cleaning, and we're just trying to be proactive on that. Without equipment supplier visibility, so this is related to the cloud side. A lot of times, even with all this good data, plants are busy and they're not reviewing this data 24/7, and it's hardly have enough time to actually do the sanitation, let alone review some of this data to take action. So the nice thing about the cloud side is without the supplier visibility, even if this plant had all of that data, maybe they weren't able to take action on it because they're just overwhelmed with lots and lots of data. What do you do with all this data, right? We're in a world where there's tons of data, but unless you can make sense of it and figure out what to do, it's not really good, right? So with the cloud side, you can kind of take some of the responsibility or onus on or off the end user side. The processor side and the supplier side can remotely review this and actually make recommendations and see what's going on with the system. And again, being subject matter experts on the equipment and how it runs, they can kind of make some insights and make some operational suggestions. Next couple of slides are some examples of system operation report of a CIP or COP system performed by the equipment supplier, and then making recommendations to take, whether it's operator train or systems performing in a certain way, and you might want to address some certain things. In this case, think of like a CIP system, and this is just kind of a example, like a 6-month running process. So over a 6-month period, last couple of slides showed where you could look at all the alarms that came up for a system. So in this case, say over a 6-month period, there's a couple different alarms that came up. There's a proof of return flow hold watchdog, a return temp hold watchdog, and a high supply temp. So a lot of you are like, what's going on with all these? These are weird alarms, right? So return flow, if you're familiar with CIP, when the flow's coming back, whether it's a tank circuit or a line circuit, you want to make sure that that water's coming back or that CIP chemical solution is coming back. So without that, it alarms after a certain set point. So this only happened 3 times over, say, a 6-month period. So it might just be kind of a nuisance thing. You could increase the timer. Let's say the timer's at like 2 or 3 minutes. You could go up to 4 minutes. So just say, hey, you might want to have that timer increased a little bit. The tank that you're cleaning might be on the other side of the plant, and it just takes some time for that water to come back. So not a huge one, 3 alarms, so maybe nothing to do, but increase that timer a little bit. The next alarm up there is return temperature hold watchdog. So in this case, when we are, say, doing our chemical wash, we are sending out hot chemical water, washing, say, our tank, and then it's coming back. So we are watching that return temperature for, say our set point's 140 degrees Fahrenheit. We want that return temperature to be 140, because if we're sending out water at 140, it's going to cool down, and when it comes back, it's going to be below that. So this one, the return temperature is below the set point, so it took longer. It could be a matter of just increasing the time, to get that up to temperature, but it happened 12 times, so it's kind of a medium presence. So let's move on to the next one, the high supply temp. In this case, this is when I have a set point for 140 that we talked about for chemical wash, but we also put limits on how high and how low we can go below that. So sometimes you have elastomers that can't handle really high temperatures, and you don't want to be washing at a higher temperature than, say, 170 or 180. So I have gone above that high temperature in this case. So that happened 55 times over that 6 months. More than just a once in a while alarm. That one came up a ton of time. And digging into a little bit more, again, you can look at all these individual cleaning cycles and see the temperature. In this case, if you looked at the temperature control curve, so we have set points recorded, but we also have the actual recorded. So in this case, the actual was going way up and down. So it was overshooting, and it was coming way back down. So our steam control valve, we're opening and closing that, not fully on off, but we're kind of modulating it. So in this case, there were some issues with the PID tuning control, and we were way overshooting, then way coming back down, way overshooting. So that would lead to the high supply temperature. And that might have also led to the return temperature. So if I was overshooting, I was maybe undershooting, and it was just not heating up fast enough to come back. Again, the recommendation to look at that PID control, sometimes those are tweaked during startup, and fixing that issue is going to fix the high supply temperature. It's going to be more of a controlled heat up curve. We're not going to get that high supply temperature. And more importantly, if you think about this CIP system, over that last 6 months, it was stopped 55 times. So how much wasted sanitation time is that stopping, someone coming back, acknowledging the alarm, figuring out what happened, restarting it, going again. So a lot of wasted time. Another example here, different circuits. So in this case, just let's call it tank 1 and tank 2 wash. And kind of look at some key data. So in this case, let's say tank 1 was a 15-minute pre-rinse to drain and 40 GPM, 150 chemical wash set point, 75 millisiemens per centimeter chemical wash conductivity set point, and then it was a program wash time of 30 minutes with the 2 microsiemens final rinse return conductivity set point. So if you're not familiar with CIP, on the final rinse steps, you are looking for pure water coming back. On a system that's not as advanced, you can just do that by time. So when you first start the system, you can say, I'm going to literally watch the rinse water come out and come back, and once it's clean after that final caustic wash, that's, everything's looking good, I can go into my sanitize step. The recommended way to do it is you'd have a conductivity sensor on the return. So as you're returning that water, you're seeing kind of a higher value, and this is exactly what these are. So this green line would be the set point of 2, and then the blue would be the actual conductivity. So when I first start rinsing, I'm at a higher conductivity because I'm bringing back some of that chemical wash and food I just cleaned off of my soils, but then quickly I'm going below that line. So in this case, for some reason, a 20-minute time was used on one tank, but you see here, after only maybe a minute or 2, I was below the conductivity set point. Now you can see there's a couple spikes here. So that could be something like a poor hygienic design where you have like a pocket in that tank. I'm rinsing out, and then kind of I catch a poor corner of that tank and I find something. So might want to look at that tank and see if there's a couple spots that we're having some troubles miss. But even without that, or if we dress that, you can see if this is a 20-minute time frame, there's a lot of time where we're just rinsing out water. We're wasting time. So you can cut that 20 minutes down to at least 10 minutes, and maybe these bad hygienic design areas of the tank or the line, if you cut those out, you can cut it down to maybe 2 minutes. So going from 20 minutes to 2 minutes on your final rinse, you're saving 18 minutes per circuit, but you're also saving 18 minutes times 40 gallons per minute, saving 1,000 gallons for every time you run your CIP system. Final example is related to preventive maintenance. Tied back to that last example, when we're doing so much of that rinsing and doing just thousands of gallons just on that final rinse step alone, we look at cycles of some of the valves. So the solution tank on the CIP system, 117 times it's opened and closed. Solution tank return valve, 156. The rinse tank fill valve, in this case, 2,200 times. So why is that so much used? Because of that final rinse. That tank is just spitting out water and we're refilling it almost constantly. It's going up and then it's spitting out and it's going up. So obviously addressing this issue is going to make that rinse tank not used as much. But until that issue is fixed, you're probably going to want to watch your rinse tank PW fill valve for a more premature failure rate than some of these other valves. So again, that annual PM on gaskets is obviously always just kind of averaged. In a year, this might be used 1,000 times, but if you continued usage of this valve, you might have used this 20, 30,000 cycles, so you start to see some premature failure.
So thank you very much. Yeah, MoCRA, you're all familiar with Food Safety Modernization Act. Well, this is the Modernization of Cosmetics Regulations Act, which has been a long time coming. So it's the first time since 1938, since the FD&C Act, that the cosmetics regulations have been updated. And There's been a lot of pressure on the Congress, on government to update the regulations because cosmetics regulations in the US compared to Europe, for example, has been quite behind the times. So I'm going to talk about the good manufacturing practices, which are part of the regulations, and then the Industry Association for Cosmetics, the Personal Care Products Council, which represents their very large volume manufacturers of cosmetics, put together a task force. So I was one of the co-leaders on the task force. I'm here talking about from my own point of view, so I'm not representing PCPC, but I'm talking you through the work that we've done as a PCPC task force. And there are so many parallels between what's happening in cosmetics, what's happening in foods, what's happening in packaged consumer goods as well. I was at a recent event in Philadelphia with the Institute of Chemical Engineers, and what's going on in hard surface cleaners, kitchen cleaners. Again, there are very many parallels, and the challenges of hygienic manufacturing are just the same in those areas as well. So it's a parallel market to food, but a lot of the things I'll talk about are very common. Just a little bit of my background. I've got 20 years with P&G and 15 years with Estée Lauder, and then some work with a contract laboratory, and now with the MoCRA regulations. So Obelis USA. Obelis is a company based in Brussels. For 35 years, we've been providing compliance to the European cosmetics regulations. So with MoCRA, we started up a US organization to provide the same service for cosmetics manufacturers. P&G and Estée Lauder, I had a bit of exposure to food. So with P&G, it was juices in Europe and the Middle East. And in Estée Lauder, it was with tea. And that's where I got introduced to the concept of an acceptable limit on insect parts in food, which was a bit of a surprise when I first came across that. Sadly, we shipped occasionally live insects and a few too many of them from time to time. So that was a bit of a problem there. My approach, it's important to the whole work really, is that, so I'm a mechanical engineer by background. Quality assurance is where I spent most of my career, and it's all about focusing on the quality systems, focusing on what the business needs. So I've been fortunate within P&G and Estée Lauder to always span both the research and development parts of the organization and all the supply chain parts of the organization. And with Estée Lauder, more and more of the commercial parts of the organization. So I can honestly say that building quality into everyone's work is essential. And the quality of that work, the quality of everyone's work is such a big driver for business. It affects the initial purchase intent, the initial purchase activity. It affects the repeat purchase, so the experience that consumers have with the product obviously affects the repeat purchase. And eliminating waste and rework affects the margin as well. And I've always believed, again, that the people with their hands on the R&D, on the lab bench, on the filling line, on the making equipment, they're the ones who control the quality. So they're the essential people. So you have to educate and train. So what I'm going to talk about is some industry changes, industry drivers, which are all very good market-driven industry drivers. And then the Modernization of Cosmetics Regulation Act itself, and then share with you, this is on the heading of the University of Cincinnati. That's had a course for the last 50 years in a cosmetic science course. So it's the oldest cosmetic science course university in the US. And when we came to them with wanting to create from scratch a course, a graduate certificate in hygienic manufacturing, then they were an open door for us. So we've now got up and running a graduate certificate in hygienic manufacturing. Task force, as I say, it was a PCPC task force. It was created out of the Micro Committee and the Quality Committee combined. Started up in May of 2021. And one of the first things we did, well, put some articles into the Happy magazine, which is what magazine now means website, which is the website for the consumer products and personal care industry. And then the next thing we did was contact 3A and say, okay, so what can we learn? So we ran a webinar really so Tim was on the call, Brian Downer from Sani-Matic was on the call. So it was really about what can we learn as a cosmetics industry from the food industry, which has been tackling this for many, many years. Then, as I say, I spoke at the conference and we said about this academic qualification. We knew we'd had lots of experience. People like me had gone through contaminations. They're not pretty. They're high pressure. They're expensive, and we wanted to do the best we could to pass that knowledge and experience on to the next generation of people coming into the industry to try to give them a faster start to prevent these things in the future. So some industry drivers. The FDA has dashboards of recalls. Looking at the preservatives, first of all, and now I'm going to the European, because most people, even down to the medium-sized and small-sized companies, will formulate a cosmetics product for global regulations. And so we have to comply, obviously, with both European regulations and US regulations. For preservatives, the EU has a list of, these are the compounds, these are the materials you can put into a product and claim it as a product preservative. They list 60 of them, a few of them you can be used, and over half of, so less than 40 can be used because of performance compatibility and so on, but over half of those, since they created the list, over half of those are facing regulatory review uncertainty. As soon as you look at eye makeup, and obviously eye is one of the vulnerable areas for makeup for contamination, then only 12 of those are on the list, which are compatible with a water-soluble pH 7 type of formulation. And 10 of those, since the list was published, have either been banned, restricted, under scrutiny. So you're down to a couple of candidates. And as soon as you get resistance to one of those, then that can be knocked out immediately as well. And there are very high barriers to entry. So to get on the list of acceptable preservatives, you have to do animal testing. Nobody wants to do animal testing these days. There are no validated alternatives to animal testing these days. Nobody's developing brand new preservatives. There's a lot of development of multifunctional ingredients, so ingredients that have an antimicrobial function, but you can't put them in and label them as preservatives. I recently chaired a discussion with the head of the European Commission Cosmetics Office and the technical head of the Cosmetics Europe, which is the industry association in Europe, and brought up what's the future for this declining list of preservatives and the growth of multifunctional ingredients. And there's a lot of uncomfortable shuffling. There really isn't a firm path forward. And the best way forward, then my summation of the thing is, there's a lot of work going on validating non-animal methods, and there's the belief and hope that as those become more accepted, then eventually we'll get to the point where more materials and compounds can be accepted as preservatives to go into products. So those lack of preservatives and the elimination of what used to be robust preservatives is a very big problem in the industry. Also growing is, and again you see it across lots of markets, natural, organic, clean beauty, essential materials, ingredients only, so eliminating lots of ingredients that used to be in there. To make a claim on a particular product, you would put a bit of an ingredient in. So now essentiality is the phrase that I think that gets used in Europe. So only essential ingredients, neutral pH, more natural ingredients, which normally have a higher level of bioburden. That is organic labeling. So there's various bodies which will give you organic labels, again put restrictions on what you can put in there as preservative. Preservatives, obviously, they're dangerous to life. I mean, they're there to kill life. We are life, so it's understandable that reduction of preservatives is an industry pressure, and it's quite reasonable that that's happening. Refillable products, there's a lot of talk about it. There's not much going on yet that I've actually seen. What I did see in the ChemE, the Institute of Chemical Engineers, is someone came along, so they're developing for hard surface cleaners, so kitchen cleaners in hard surface, a tablet which you buy the tablet. In your home, you take your bottle, you take your water and drop the tablet in, and hey, presto, you've got your cleaner for kitchen surfaces. So when you do that, you're taking a filling process, which is sometimes difficult to control within a manufacturing environment, and you're moving that into a person's home. Where did that bottle come from? What was in there? And then you've got the worry about how do I preserve that and stop it starting to smell, contaminating my surfaces, and so on. So again, it's a huge challenge that the industry is facing. Just on hair care processing, hair care products, so 20 years ago, most processes were high temperature. To make an emulsion, you went through two different tanks. Those tanks were high temperature, they were combined at high temperature, homogenized at high temperature. These days, it's a single tank cold processing for shampoos. Conditioners, again, you've gone through from high temperature, multiple tanks, down to a single tank and cooler processes. Styling products, you've gone from high alcohol down to low alcohol. So the formulations are changing, and the processing of those formulations are changing. And all that is combined with a problem of outdated equipment. The facilities, the utilities, they were all designed in a time when you had robust preservatives. So parabens was a family of preservatives which were very strong preservatives. They were, I'll say, unfairly targeted. People just had to take them out of their products. I'll say, from my point of view, abused a little bit, because they were capable, they were such capable preservatives that they were capable of masking some of the problems in the manufacturing environment. The preservative is there just because people take the products, they either apply to the lips and then multiple times, or they stick fingers in it multiple times. So the preservative is there obviously to protect the product in use. So those elimination of the very strong preservatives expose all of these problems with outdated equipment and outdated practices. Manufacturing hygiene is just, again, as you all know, it's a balance. All the risks have to be balanced to avoid having a serious problem. If you take an action to remove robust preservative systems, if you've gone to a higher bioburden, natural, clean, environmentally friendly formulations, if you've changed that side of the balance, by definition, you have to take some action on the other side of the equation of this. And in English, this would be a seesaw. I think teeter-totter is the alternative version of it. But if you introduce significant change on the formulation of the preservative side, if you don't take action on the other side, you've got major problems. And, well, microbiological contaminations are the major cause of recalls by quite a large margin for cosmetics and other categories of products. I'll talk now about MoCRA itself, the regulation. It covers a range of different things. I'll talk about in detail good manufacturing practices, but these are some of the things that MoCRA does to the industry, or the requirements that the industry must follow. So a brand owner, so anyone placing cosmetics on the market, and again, there'll be no surprise here, they have to list the products with the FDA. Adverse event, they have to collect adverse events, plot trends, act if anything happens. If there's a serious one, report it to the FDA. Obviously, there's now a level of safety substantiation which has become a little bit more defined. There are labeling regulations. Fragrance allergens, so the FDA has to come out with their list of fragrance allergens by the middle of this year, and then there'll be a public comment period and then finalize them. And then FDA has access to fragrance records. For facilities, anyone owning or running a facility which processes or manufactures or fills cosmetics have to register their facility. Everywhere in the world has to register their facility and comply with the good manufacturing practices. And it's the GMPs that I'll talk about in a bit more detail. So what does the FDA have to do on GMPs? First of all, Congress said to them quite strongly, and it appears more than once in the regulation, you have to look at international consensus standards. So don't just sit on your own and develop GMP rules on your own. You must look at international consensus standards. Obviously, it's intended to protect public health and ensure that products are not adulterated. And the reason I emphasize that is because the FDA, they did list some GMP guidance for industry in 2013. By then, ISO was out in 2007 with ISO cosmetic good manufacturing practices. FDA looked at those and said, okay, we looked at them, here's our version. So at that point, they've not embraced ISO up to now. They have to come out with a notice of proposed rulemaking this year. They did have a listening session. So in June of last year, there was a listening session. Lots of people participated, and they got lots of feedback, which is, look, ISO's out there. It's been in Europe for many years now. It's been adopted by multiple countries around the world. The training is out there, the assessors are out there, the inspections are out there. It may not be perfect, but if you're going to go on your own path and create your own GMPs, which they do with drugs, of course, and cosmetics which are anti-acne, anti-perspirant, anti-dandruff, are regulated as drugs. But if they go down that path with cosmetics, with probably up to 1 million products that have to be listed, many, many thousands of facilities which have to be regulated under this, then it's a tough ask to go and police the world. So they got a lot of feedback that says you really need to look at ISO, and they've got Congress telling them you have to look at international standards. But whether it'll take a large step, I think, to go and really embrace ISO. So that's what we're kind of watching for, how close do they get to that. Interestingly, in the med device world, the FDA have just recently, in February of this year, they did align more with ISO standard for medical devices. So they're beginning to move in that direction, but the level of international assignments is going to be fascinating to watch over the next couple of years. I mentioned the FDA guidance itself. The language in there, it's very general, but it'll be no surprise to you. Of course, equipment has to be suitable, able to be cleaned. Utensils, transfer piping, cosmetic surface finish all have to be well maintained, clean, sanitized, et cetera, et cetera. So there's some general language in there, as you might expect. This is ISO 22716, which is the ISO equivalent. And again, they've got language in there, obviously, which says it needs to be suitable for the intended purpose, designed to prevent contamination, protected from air contaminants, again, et cetera, et cetera. So the kind of language that you would expect to see in any good manufacturing practice regulations in any industry type. And then NSF have a standard, NSF ANSI 4553, which is, again, is good manufacturing practice for cosmetics, which really that's very, very closely aligned to ISO. It encompasses ISO, adds a bit more detail. And so if you comply with this standard, it encompasses ISO. So you also apply with ISO as well. And those are really the alternatives. The FDA can go out on their own again, or they can go embrace ISO in some way. And NSF has a way to embrace ISO in some way. So we'll see which way they go. So now, as I say, the task force came out of the PCPC, and we wanted to create a college graduate certificate in manufacturing hygiene. And the target audience was, as I say, new recruits. So graduates who are interested in scientific engineering career, who we could explain really more about the cosmetics industry and manufacturing hygiene in this kind of environment, or entrepreneurs. UC, University of Cincinnati, as I say, has been going for 50 years, so they've got a long-standing cosmetic science program, and they have quite a number of entrepreneurs, so it's easy to start up a small brand in cosmetics with TikTok and other ways. You get yourself a profile, get yourself a contract manufacturer, they'll formulate it for you, you're up and running, you're at the races. So it's very easy. So we get a number of the entrepreneurs who've got their own brands who want to learn more and understand, okay, before they get too embroiled in this, what are some of the risks that they're taking? Or for the larger companies, training the high potential managers and so on. Contract manufacturers work for a lot of, again, the big companies, so they were a key target to bring up to standard. And as I say, it's the major cause of recalls in multiple product categories. We did a survey of PCPC companies. Again, these are the largest companies, the largest multinational companies. I'm sure you could name all the big companies are members of PCPC and say, okay, what's your biggest gap? And you look at the top, and I mean, again, I forget how many were participating, but 27 of them came back, or we can work it out if we had the time. But 81% of the respondents said, my biggest gap is hygienic engineering flaws in my legacy equipment. Next one down, thorough understanding of microbial clean design in equipment and facilities engineering. And then in-depth microbial risk assessment in the plant, so the construction, HVAC, process flow, receiving to filling. So those were the top. It's that problem of, again, legacy equipment and legacy operating practices in a world where the formulation is changing, the robust preservatives are disappearing from use. So we created this postgraduate certificate in hygienic manufacturing. To get the certificate, you need to have 12 credits in total. So we created 2 new courses. The first one ran in the spring, and then the second one has just started last week, the second semester. The first new course we have is like microbiology, product package design, quality assurance. It's really applied microbiology, so one of the prerequisites for the course is to have some microbiology education, so you know a little bit about it. And then we come in and make it, introduce applied microbiology within the manufacturing environment. And then same with facilities, utilities, plant engineering, that you need the microbiological training just to understand that, just at the basic level. And then what the university did, they run a master's course already in cosmetic science. So they said, okay, we've got lots of other options. Students can add 8 to 11 credits by just choosing part of the master's course to make up the graduate certificate in cosmetic science. So it's run both as an elective within the master's program, or it's run as a graduate certificate in its own right. So you sign on, you want to do the graduate certificate in hygienic manufacturing, or you sign on and say, I just want to take one course. You can take the 2 new courses on their own. You don't need to go on to take a graduate certificate if you don't want to, if you just want to learn these new syllabuses that we've got. It's all asynchronous learning, so it's all recorded lectures, so you can do it in your own time. Most of the people are working, they're in work, they're doing work of some sort or another. They're mostly in the US, but also, I think this summer we had somebody from, I forget if it was Rwanda or Uganda, one of the African countries, the Caribbean, Puerto Rico. Again, we're doing the Getting to Know You exercise this week for the summer. And again, we've got Puerto Rico, we've got Barbados, and people are spread across the US. And it uses just established academic support system. So because we're building it onto an existing program, then it's not too difficult to run the program because we've got the full support of the University of Cincinnati. So as I say, you take the 2 new courses for the graduate certificate, and then you can choose other courses to make up the full graduate certificate, and these are the other courses that are part of the MSc program. So you learn about how to formulate products. And this is why I think we were so welcomed by UC. They've had this course for, let's say, 50 years, and it really kind of stopped at, okay, you've formulated it, you've defined your preservative system, okay, you're good to go. And they know perfectly well you're not good to go once you've done that. There's all the manufacturing, all the regular supply. There's a huge challenge in that. So they were very welcoming to build this into their program. So that's how you make up the graduate certificate. The syllabus for the microbiology product package design, getting into the biofilms, preservatives, and the growth of the natural biofriendly products, so what impact that had, because this is a market-driven requirement, what challenge that brings into the plant. And it was really designed for 2 kinds of people. What we had in mind was very much a manufacturing hygienist, which is not a common term in cosmetics. Some of the big companies are using it. Other companies will say, well, I take my microbiologist and I make sure they're heavily involved in equipment design, equipment approval, and so on. But as a job, it's not very widespread in the industry. So we said we want to train people in enough breadth knowledge to engage with the experts, so to engage with engineering, to engage with R&D, to engage with the people doing the formulation, to engage with the process engineers, to engage with manufacturing operations. So we envisage it as the manufacturing hygienist is the conductor of the orchestra. So the music comes from the experts, the people playing the instruments, but the conductor has to have enough ability to coordinate those and speak the same language to make sure the music comes out as it should. So we wanted to train potential manufacturing hygienists as this becomes more and more understood as a discipline. But we also wanted to train the specialists, the R&D people in, as you do your job, these are all of the other factors that are in play in this, so you need to understand more than just your own role in formulating. You've got to understand all the implications of any decisions you take in formulating. So it's there to give everyone a working knowledge of this big breadth of subject, which is hygienic manufacturing. So microbiological daily management, then quality control, quality assurance, the regulations, the role of regulators, and then something I wanted to put in, and we did put in, is when the stuff hits the fan and you get a microbiological contamination, very often it's at a launch and all of the marketing money's been committed, the distribution's all secured, the trucks are on their way, and then everybody's very excitable. So when everything shuts down for several days and you're waiting for microbiological test results, everyone is very excitable. And you need to understand that. So when you're in the middle of it, you need to understand the context, the business context in which you're working, just to understand, before you get into this situation, what you'll be faced with. And so being a little bit armed with how important these things are and how important communication is. And talking of communication, then there's a bit about just individual motivation, what motivates individuals, how to build a team, both in normal times and when you're in the middle of a recall. How do you work with people? What are some of the factors that work for building a team and aligning a team to fixing a problem? That was, again, part of the syllabus. For facilities, utilities, plant engineering, hygienic design, so all the stuff you're very familiar with. Like Brian Downer, again, helped us from Sani-Matic, gave us some training material. There's a number of other companies. I haven't heard the name mentioned, but I'll bet they're also members of 3A, who are service providers to the industry or manufacturers of equipment to the industry, who gave us training material for this. So as I say, it's all recorded by brand owners, contract manufacturers, service providers, equipment providers, to get across their experience of the industry and what all the stuff we've been talking about over the last couple of days of slopes and curves and so on and so on and so on, about how to design and run a manufacturing facility and all of the utilities. Cleaning, sanitizing, how you do that, how you validate it, obviously key parts of this. So is water system design. So we've got 2-3 weeks on water system design, testing, validation, HVAC, compressed air system, environmental monitoring program, and then all the microbiological investigations. And it's built through with case studies as well. So it's pretty comprehensive. And really this refers to the first semester. We had, let's say, 20 plus members of the task force who put this training material together. 26 students enrolled on the spring semester course, which was the microbiology and quality assurance. And there were 24 students when I wrote this. I looked this morning, and although it started, we're now up to 32 students on the summer course. So they're enrolling even though we're already in the first week. We've had a very good response to the course. And we did a survey after the spring semester, and the feedback we got, again, was very, very encouraging. What people like is the fact that they're learning from experienced people, sharing their expertise, sharing their value, and they're often using this already. So we asked them, what was the most important part? So biofilm removal strategies, help somebody who was having a micro issue. Again, they're entrepreneurs or they're people in R&D positions, got 14 years of experience in contract manufacturing and R&D, and they're using this already to contract manufacturers since change their sanitizing solution and frequency of sanitizing. It's been very, very gratifying to get that kind of feedback. And again, so I've not had exposure to large manufacturing plants and the hygienic processes, so in some cases you're talking about people who've got, maybe University of Cincinnati has a good cooperative program, so some people have got some industrial experience, but you're taking people who, in some cases, have not got manufacturing experience, to others who are already in manufacturing and are using this to just broaden their knowledge and apply it to improve it. The support we've had from the Personal Care Products Council, so as I say, we launched it in 2021. PCPC runs a science symposium every October. We had a microbiology workshop, and there were 3 presentations, then that one workshop, which were all about hygienic manufacturing. We had a quality workshop. There were 2 subjects about hygienic manufacturing. FDA attends these. They're very active in coming to these PCPC workshops, and they're very involved and pleased to see the industry really addressing this significant problem. In the 2024 symposium, then we had training on the next generation of microbiologists, which also covered this subject. One of the questions we got, somebody asked, look, is good manufacturing practices, is it really going to have an impact on the cosmetics industry worldwide? So I said, well, the cosmetics is an offshoot of foods, if you like. In the FDA, it's a small part of foods. We know the cosmetic office is about 30 people. It's not large. So what I said was that, so obviously once GMPs are there and inspections start, it will have an impact on the industry. So standards will rise. But I said, to be honest, I would say that the large companies, the large brand owners, can do more by putting pressure on more contract manufacturers to increase their standards and improve than FDA can do on their own with like 30 people. And so, I got some nods of agreement from the FDA there. So I mean, this is important, I think, something that we're trying to get across. I think my point is, it's absolutely market driven. It's the right thing to do to go to natural products. It's the right thing to take out extraneous raw materials that don't need to be in there. They all go down the drain. They all affect the environment. Sustainability is real. It's important. Preservatives should not be used extravagantly. Those are all things that you have to do. But please don't think that you can take those steps and leave everything else not looked at, not addressed, unchanged, and avoid just getting deeper and deeper into microbiological-driven recalls in the market. So the industry benefits we've got, so this is now a course. So as I say, it's up and running, it's there. It's available for training in-house talents. As I say, the large manufacturers need to be putting pressure on their contract manufacturers to improve their contract base. And it's there because these recalls, they have a large financial impact, they have a large reputational impact, and when something happens, when a product does get recalled and that gets publicized, no one can hide behind the fact, that's not my brand, that's not my business, that's those people over there, because it tarnishes the whole industry. You know, people don't draw the distinction. Once a shampoo starts getting horribly smelly, starts getting in people's eyes and starts causing health problems, they don't remember exactly whose shampoo it was. It's the industry that gets affected. So it's important that we just keep on pushing this whole hygienic manufacturing message forward. And of course, it's a gateway for attracting graduates into the personal care industry. It's those of you who are in the industry, foods industry, anyone who's in an industry finds it's far more fascinating and there are far more challenges than it maybe looks at from outside. So that's my UC email on there. So if you're interested, and this should be published, I think, so that you can look on the web and find this graduate certificate in hygienic manufacturing, a UC. Thank you.
Good afternoon. Thanks for coming to this session. We're going to do some discussion on hygienic redesign and how we problem solve equipment that is already existing in a facility. And we were here Tuesday and learned all about the design process of going through our hazard analysis, looking at what 3A means to new equipment. And then we think, man, I've already got a lot of equipment in my site that doesn't have any 3A on it. So what do we need to do about that? And that's what we're going to talk about today. I'm Josh Burgess. I'm the Corporate Sanitation Manager at McCormick. We are your favorite spice company, right? We make Old Bay, we make all the red cap spices that you use, especially on the holidays, but we also do a lot of work in condiments. We have the leading hot sauces. We have Cholula, Frank's hot sauce. So if you like hot sauce, come to us, right? We've also got barbecue sauces, marinades, and we do a lot of industrial work on flavors. So when you think McCormick, you might think dry, but we're all over the place, and it causes a lot of variance in our sanitation programs and what we're doing with our equipment. So today I really want to walk through what we do at McCormick when we do assessments. How do we determine what our risk is with our equipment, what that means to a site of evaluation, how we document that well, and how we collaborate, because it is not a single member that does that work, and it's something that takes what we call the whole McCormick brain. Then we're also going to look at what do we do once we know we have a risk. Right? We probably already know we have some risk, but we don't want to be an ostrich. We want to know what that risk is, but what are we going to do about it once we know? Liz told us some pretty concerning things this morning about a cantaloupe system, right? They knew they had a risk. What did they do? Not enough, for sure. And so we don't want to do that. We have to make some decisions about what we're going to do. We're going to make physical changes, or we're going to make a program change. So I'm going to tell you how hygienic design affected me early in my career. I had no intention of being in food manufacturing. I went to school to be in industrial management. And I was very excited to get into manufacturing. And the first company that called me back made food. So here I am. When I was working in a processing plant, we had an issue with hygienic design, and it taught me early on. So my initial hygienic design training did not come from a seminar, a summit, a class. It came from real life experience. And I can see some nods of people thinking that real life experience is what really gets to you, and it teaches you a lesson. So I worked in a meat processing plant. And in this plant, we cooked some chicken, sent it through an oven, came out really hot, 165 degrees, of course, maybe a little bit hotter. And then it went through a refrigerated process, went through a nitrogen tunnel to get it cooled down fairly quickly, and then into a spiral freezer. That all sounds reasonable. We had a pretty good process, no issues. But we're going to talk about this nitrogen tunnel. It's about 6 feet by 15 feet long. We'll just call it a stainless steel box with a conveyor going through it. It dips into a pool of nitrogen. At some point, a decision was made that the process should be changed. And when we changed the process, we took the nitrogen out. We didn't need it anymore for whatever reason. Maybe yield changes or throughput, capacity. Doesn't matter, but the nitrogen wasn't there. So, pop quiz for you. If you have a nitrogen tunnel and you take the nitrogen out, what are you left with? A tunnel. Is there a 3A standard for a tunnel? I don't think so, right? So what could go wrong in a tunnel full of hot meat? Yeah, we all know the answer. Nothing good, right? Technically what that's known as is a mess, and that's what happened. And so if you can think about what happens over a 20-hour shift of hot meat going through a stainless steel box, you get a lot of buildup. You get protein, you get moisture, and you get just the right temperature because it's a refrigerated area, but you got hot meat going through it. So you know what happens. And this brings us to one of my favorite quotes of all time, is that a bad system will beat a good person every time. And that was a very bad system. The reason it was bad is because the process changed. We took a piece of equipment that did its job the way it was designed, and we changed the purpose of the equipment. Did we do any process change management on that? No. Did we look at the hygienic design and consider what would be different because of that process change? No. So then, of course, we ended up with these unintended consequences. So my challenge to you as you think about what's in a site that you might have right now is, do you have any equipment that was designed for purpose A and now it's on purpose B? Or maybe it's purpose A.2, right? You've done a little bit of modification to it. It's not completely different, but has anything changed? Because that is where those unintended consequences come in. So how do we figure that out? How do we know what our risks are with our equipment and what we're going to do about it? Well, the best way to do that is through validation of your sanitation. Since I'm a sanitation manager, that's what I like to focus on. But a key part of sanitation validation is sanitary design and hygienic design evaluations. It's a key element. When we think about what sanitation validation is, it's a really simple process. You want to know that do you say what you're going to do? And do you do what you say you're going to do? And then when you do what you say you're going to do you get the result that you expect? And so the first part of that is having a good SOP. So if you look at your SOPs of your sanitation program, and they're pretty limited, if they have the 7 steps of sanitation listed fairly simply, you should just go ahead and add the 8th and call it hopes and dreams, because that's what you're running on. So when you have an SOP, you really want to think about details. You want to think about where those risk areas are in your cleaning process. And so when we look at an SOP, we got to think about what are those critical fail areas? What do we need to incorporate directionally for our operators so they know what they're going to do and what they're going to clean? And the way that we find that out is through a hygienic design evaluation. So that is our first step. We have legacy equipment that we're concerned about. We really need to know what we're concerned about and not just think we might have a problem. So this picture is a piece of equipment that processes a meat product, a liquid meat product. Sounds great, I know, but trust me, it comes out good. As you can see, it's been cleaned, it's been rinsed, it's been soaped, probably been scrubbed because we don't see any food debris on it. But from the audience, right, what do you see as a concern on this piece of equipment? Doesn't drain, that's a good one. I want you to look at these recessed screw heads that are right in the middle of the equipment. Do we think those could be a problem? That is definitely a design issue. Why? Because of the recessed area of the screw. And so we know it's a gap. We go to our SOP, is it there? Maybe, maybe not, but if it's not, it needs to be. Because we want to make sure we document these hard to clean areas and these things that the operators need to know about. And that way, we're reminded too to train them on these need to know areas. So when we just look at this on the surface, we say we don't want recessed screws. So let's dig into the equipment a little bit, and what do we find? A much bigger issue. Not only was the recessed part of the screw a problem, but the whole assembly was screwed on and caused a lot of hidden food debris that if that wasn't taken off, carries over to your next product, carries over to the next week, carries over to the next month. So this is why we're concerned about doing this evaluation. Going through the assessments is a process of detail. It's taking the principles that we know about hygienic design and going through almost with a fine-tooth comb. We want to seek out those harborage areas that could be a problem and disassemble to the smallest component. That's often overlooked. You might have small pieces on a piece of equipment that you just consider that's the way it is. We don't need to take it apart. And I'm not saying that you need to take things apart to the smallest component every time you clean, but when you're doing an evaluation, you definitely need to do that. You need to get your eyes on it, and you probably need to get some swabs on it. And to do this well, you need to be collaborative. You need to not go out solo or with a limited amount of understanding of the equipment. I live in the quality world, food safety world. I can't do this well without my partners in engineering and maintenance. Why is that? The maintenance guy, he knows what smells bad when he does his PM. He's seen more stuff in the equipment than anybody else. The sanitation operator, he knows what's not working well in this equipment too. Operations, a different perspective. So really these assessments are not something we think about as an engineering function or a quality function, but they are a team function, and that is how we have to address these food safety activities. So when we look at what the risk is of a design flaw, we know that when we go look at our existing equipment, it is not going to be perfect, right? If you have perfect equipment, you are free to leave the room now. But you don't have it. It's almost impossible, right? Only the most simple equipment can be completely perfect in terms of hygienic design. Once you get complexity, it comes with more questions about where the risk is. It depends on what products you're running. It depends on what the characteristics of the product are. What is the risk inherent to the product? So all these things are a factor in the design evaluation. It's not just as black and white as what's going on with the equipment, but it's what's going on with the equipment and what can that do to the product. When we go through the evaluation, we want to consider those food safety hazards. What's severe and how probable is it to be a problem? But I'd encourage you too to look at what's happening with your quality attributes of your product. You can also affect negatively products from aroma, taste, appearance. If you're making a white cheese and you have a design flaw where you have a recessed area, maybe around a blender shaft, and then you have the white cheese and it comes out with some red streaks because you had a red product before it. That's a problem, and you need to address that. So as we think about where our risks are in design, it's not solely about micro problems, but it also affects our quality problems. When we do the assessments at McCormick, we use a very standardized method to do that. And I think that is the best approach, is to have some consistency in your methodology. I'm happy to see my CFS friends here today because I stole this form off of their website. So it's a great resource. There's a link down here, but if you look at CFS website, it'll be there. But this form has been around for a long time. There's other options. This one was the GMA, there's the AMA, there's any sort of checklist that you want to use, develop your own internally. It's all fine. They're all based on the principles of hygienic design, but you need to standardize your assessments. You need to have prompts for the questions that you're going to ask. And those prompts of questions is where the real fun comes, right? When you have quality and you have engineering and maintenance debating about what's a risk, there's some really good discussions there. When you look at this form, you see some colors, green, yellow, red. Green, we're marking something satisfactory. Yellow, we're saying it's marginal. Red, we're calling it unsatisfactory. Those two border areas, green and red, those are pretty clear. Makes sense to everybody. But how do you determine something's marginal? And that's really where you talk about what the risk to the product is and how likely something could happen. So as we dig into assessment, we're going to talk about the principles versus the practice, right? So we have these principles of good hygienic design, and we capture a problem. So this is an example of a design issue. We've got two issues that were identified. One being some open threads on a bolt. If you look at the notes, it says it's recommended to be a solid, smooth standoff. That's pretty easy. That's a pretty easy fix. Not bad at all. We can handle that. Number two, it has a bushing that is not removable without tools. It's a sleeved assembly. It's not readily accessible, and it's going to require tear down or a cleaning activity or a design change. Now, this is where the pushback comes, right? Because if you say design change, there's probably going to be a reason they chose that part. As a sanitation person, I don't care. I want a different part. As an engineering team member, you're going to say, get over yourself, right? And so that's where we have to meet in the middle. What are we going to do? We have to make decisions because we know there's a risk. But what you also have to think about is not all risks are the same, even for the same type of design gap. So you've already seen a piece of equipment over on the left. It's got some exposed threads on it as well. The one on the right, same problem. The one on the left, wet meat products. The one on the right, dry spice products. How do we feel about those? Are they equal? Is the problem the same? No. The design's the same, but the problem is not the same. So we have to always consider what we're looking at and not be blinded by just the process of the checklist. So when we fill out information about design gaps, I want to spend some time talking about the real value of documentation. We want to be very clear about what that gap is. Just as we looked at two different types of equipment, same problem, the gap's probably not going to be described the same way. As we describe it, we want to be very accurate about what we see as the problem. That way, we're not going to make decisions when we're doing the evaluation necessarily. You don't come up with the solution just when you find the problem. You need to work that out together. So capture that with pictures as well. We already know that pictures are worth 1,000 words, which 1,000 words are worth 2 pages. So unless you're typing up 2 pages of descriptions for every gap that you identify, you're not doing it justice. So just take the picture. And why do we care about that? We care because we have future readers of our information. This is a major opportunity everywhere that I've been and seen in multiple companies. The evaluation should be documented for not just yourself or the team that's doing it, but for the people that come behind you. you or the team members that you have probably changed jobs in the last 2 years. You're probably about to get promoted to the vice president of awesomeness, and you're not going to be in charge of this anymore, and somebody has to come behind you. So the question is, do we expect them to go through, do the same amount of work, maybe come up with different ideas, or do we come up with a solid document that can be acted on in perpetuity until we get the issues resolved? And that's what we want. We don't want the risk to be lost. So we know we have risk, and now we know exactly what those risks are, and we've got decisions to make. We've got 2 paths that we can take. Since we have the gap, we're going to do something. We have to decide immediately, is it critical? Do we need to shut down and fix it? Or is it something we can decide on? And so you have really 2 options. Redesign, which is what we really want, or redesign your program, your sanitation program, your maintenance program. Now, this is risky, but it's an option. And it's definitely better than taking no action. Why would we want to change a program? We would change a program because the cost is prohibitive. It's not feasible to do a physical change for whatever reason that is. And so let's talk about time and money a little bit. When we know we have an issue, we want to get to perfection. The harder we work to get to perfection, the higher the cost gets, right? What's the engineering triangle? Quality, time, and cost. You can get 2 of the 3. How do we decide what we're going to do with our equipment now that we have the risk? If we push to perfection, we come to a hazard area. And this is a place, as a quality sanitation person, you don't want to be standing on the cliff of unreasonableness with a room full of engineers behind you, because they might just push you off. We can't be unreasonable. We have to make common sense decisions with the assets, with the allocation of funds that we have, with the resources that we have. So again, the selection of corrective action is not always just fix the equipment. So we think about what are our options. How do we decide what we should fix, and how do we decide what we should change a program for? Well, we want to think about the impact. And impact is that total cost of failure. And so if we have a design issue and it leads to failure, and what would failure involve? Failure would probably be a microbiological failure, or it would be a quality issue, and that's going to result in product loss. It could result in capacity loss. It could result in major downtime. So there's lots of factors to consider other than just the immediate loss of an event. And so as you think about those, what are low risk, high impact versus high risk, low impact? Example of a high risk, high impact issue could be a hollow shaft inside of a product zone. And it's got something tapped inside of it. If we have a tapped hollow shaft in a product zone, we're looking at a pretty significant issue. We've got potential for ingress of moisture that could put a pathogen directly in the product zone. If you put a pathogen directly in the product zone, what happens to all of your product? It's all gone. How long does it take you to figure that out? Multiple days. So now you're losing weeks of product and you still don't know where the issue is. So high risk, high impact, we want to do something significant. That's probably not a good candidate for a sanitation program change or a PM change. If something's low risk, low impact, what could that be? Well, like if your framework on equipment is not set at a 45-degree angle so it auto drains and it's 18 inches from the floor, is that what we want? Not necessarily, but it really does not have the same impact as something in the product zone. So we have to be reasonable and considerate of what the things we want to change are. If you leave here this week, go back to your plant, say, we should really change all of our framework from square tube to round tube, or at least set at 45, you're probably not going to be very respected anymore. So we can't do those types of things to the extreme. We have to be reasonable, think about this options analysis. And going through options analysis is another activity that really takes a team. It takes the full group of engineering maintenance, operations, sanitation, quality, food safety, and really what's important here is that people are trained on what they need to do. We learned about the 3A Knowledge Center the other day. That is an excellent resource for basic foundational hygienic design training. If you have team members that need to participate in these types of evaluations, put them through those modules and get them introduced to the basics of the process. If you're having struggles coming up with what ideas are, I'm sure there's manufacturers in here that will be willing to help, like figure out what our options are, what are some things that they've seen at other sites. Or if you have a network of sites in your company, go ask what they've done about certain issues on equipment. The magic of sanitation, hygienic design problems is that it's been around a long time and a lot of people have solved these problems. So we've got to tap into the resources, get into our networks, and figure out what the best options are. So as we think about what to do, we think about the cost to fix. Is a $20,000 fix today a better decision than a $1 million loss a year from now? Those are tricky calculations to come up with, and a lot of times loss avoidance doesn't really convince a lot of people. But we know that it's possible. If there's a history of issues on a piece of equipment and you can demonstrate that the trend is rising, that the water's coming up, perhaps you can get that funding that you need to make those permanent changes. Whatever we do, whether it's a permanent fix for the physical modification or a program change, we want to confirm that it works. We don't want to just say, well, we replaced something, because if we just replace something, there's also the possibility that we've created a new unintended consequence. So we really want to stay on top of the management of the change, how we monitor that with our micro system and our physical inspections after sanitation. So don't just set it and forget it, right? But really stay on top of it, monitor and assess that through time. So regardless of what we choose, there's pros and cons. Physical changes, again, are our best option. It gives us a permanent solution, it eliminates the risk, and it really takes human error out of the equation because we're not relying on somebody to do some work. The cons of physical changes can be very cost intensive and sometimes prohibitive. If you have so many issues, you need to completely replace equipment, that's a big issue, and you probably don't have that quick fix to do that, nor is the equipment going to be ready to go. For program changes, it takes a lot of documentation, but the documentation is concrete, it's recorded, and it is there for a program. It can be acted upon. You're not telling somebody to go clean something every once in a while, but you've changed their actual SOP. You've changed their PM so that it is in a system and you've automated that process, right? It's less initial cost to throw people at the problem. It reduces the risk. It doesn't eliminate it, but it does bring the risk down, so we're a little bit more confident in that. Bad part of program changes, highly dependent on management. Lost knowledge resulting from people leaving, right? Again, once you're promoted to the VP of great things, the next guy comes in, says, I'm not sure why we're cleaning this every 3 months. That seems ridiculous. Let's go to a year. He doesn't have any information. He just made a capricious change, and then you're back to having a problem. So those are the risk of program changes. While they're good alternatives, but they're not solid always. Even though we want physical changes, sometimes we just can't do it. This is a very simple example. This is a filler piston with a collar that's been welded on, and that collar keeps spacing in the fill tube. This is not a good design, right? There's no alternative control for this. How do we work around this bad design? You can't clean in the crevice. You can't inspect in the crevice. So even though this is simple, it demonstrates that sometimes your only option is just change it and not try to deal with the issue that you found. The problem with putting program changes in place, again, is if we expected somebody to clean that, do they even have the resources to do it? No. You could try to throw it in a COP tank. That's not going to work. You're just going to create more problems. So let's fix it when the physical attributes of the equipment dictate that. So when it comes to program controls, we want to make sure that we give people the standard method to execute the program, right? I've got a picture of a shadow board up. Why do we use shadow boards? Because it makes the thinking easy. We don't want people to have to wonder where to go put their tools. We say, go put your tools right here. I have these all over my house for my kids, and they work great. They totally ignore them. But think about a shadow board, and then think about your program. You want to have the program almost on autopilot, right? If I found a design issue that I have to address with a disassembly, a changing of a gasket, a total breakdown of a butterfly valve, I need to have that in a program where it comes up as a task and it's telling somebody to do it. They don't need to remember once a week I have to go hit a butterfly valve, or once a day, I think is what we heard the other day. But we want to automate that so it's clear that that's the work that needs to be done. Determine that frequency, and a lot of questions come up about master sanitation frequency. How often should you clean something on your MSS program? And sometimes you just have to make your best guess. So that's the place to start. Always evaluate and modify as needed. Again, whatever you change in a program, continue to monitor. Don't let it be forgotten about. Always continue to assess, because while the risk has been reduced, it has not been eliminated. So that's the overview of what we look at when we do a hygienic design assessment and consider what needs to happen from a redesign standpoint. The assessment is critical because it really identifies those risks, it puts it on paper, it makes it real, and it's not a guess. And then we have to make our decisions about, are we changing a program? Are we going to ask somebody to clean something instead of making a physical change to our equipment? We want to make as many physical changes as we can to eliminate the need to put resources against it. Because as we think about lifespan of the equipment, resources against it adds up over time. 2 people to do a total breakdown on a piece of equipment once a week that takes 3 hours over the course of 10 years. You got a substantial investment in that. You probably could have solved for a cheaper cost. So when we redesign, we want to take our options analysis, make the best decision that we can, and know that at the end of the day, it might not be perfect, but it's a lot better than when we started, and that's our goal. So hopefully this was helpful for you to understand how to approach hygienic design assessments of existing equipment and what your options are when you look at trying to address that with corrective actions. I really appreciate you coming today.